Welcome back. Today we're going to continue with our third unit, Chapter 6, Section 6.5. This is graphing square root and cube root functions. After completing this lesson, you will be able to graph radical functions and state the domain and range of the given radical function. Make sure you have these in your notes for tomorrow, along with the following notes. Okay, parent functions. Parent functions are both the square root and cube root functions. Square root function is f of x equals square root of x. Remember, f of x is really just y. That's function notation. So y equals the square root of x, and y equals the cube root of x. Those are the parent functions. They're the most basic. Remember, that's what a parent function is. It's the simplest form of a type of function that lets it remain that type of function. So square root of x, you can manipulate it. We may add or subtract or multiply or divide x by things inside of the square root. Outside of the square root, we may add or subtract as well. Multiply, divide, so you can manipulate equations that way, but remember the most basic is square root of x, and then same thing for cube root of x. The domain for square root of x. Well, what numbers give us problems when we're trying to take the square root of them? That's negative numbers. So our domain is going to be all real numbers where x is greater than or equal to 0. Or positive real numbers is another way to say it. Okay? So all real numbers, x greater than or equal to 0. Put a little comma in there. In our range, now this is before we move them around, right? When we move these function values around, add, subtract, multiply, divide, the domains and ranges can change. But when we're looking at the parent function, it's all real numbers. And if you look at the graph I have down here, you can see all the y values are above the x-axis. So also all real numbers where y is greater than or equal to 0. Cube root functions, if you see the graph, it's just this sideways S shape down here. It stretches on and on, left and right. So it goes forever and ever in both directions. And that's because we can take the cube root of negative numbers. We can take odd roots of negative numbers. It works. Don't believe me? Try doing the cube root of -5 in your calculator. It will give you an answer. So our domain, if we can get an answer for any number we plug in, it's all real numbers. Our range, it's hard to tell with this graph, but it will slowly increase as we go to the right, and it will slowly decrease as we go to the left. So eventually we can get to any real output number we want, so we put all real numbers for range and domain. So the base equation, standard form for the base equation is just square root of x, cube root of x. That's the parent function. But if we don't look more at the standard form of a square root or a cube root function, they are the form a times the square root of x minus h plus k, and cube root a times the cube root of x minus h and k. Where h and k are kind of the transformation, if you will. They're the values that tell you if you're going left, right, up, down. So h, k are left, right. That's what h does, and k is up or down translations. So that's what it's going to be for both these. It's just like when we had quadratics back in chapter 4. The h and k were where the vertex were. In other words, where was the vertex moved from the origin, right, left, up, down. So it's the same idea here. That might help us determine where it's going to be moved from. So it's going to help us with the domain and range. So they want us to graph these functions and find the domain and range. That's what you're going to be asked to do in your homework. Let's look at the first example. X 1/2 square root of x minus 3 minus 1. Well, first you're going to put it in your calculator. Go to y equals. Let's plug in 1/2. That can be alpha y equals. Enter. It'll give me a fraction sign. I can also just put it in parentheses. I can also do 0.5. We do the square root. That's second x squared. Square root of x minus 3 minus 1. Okay, we're going to graph that, see what we get here. So, looks like to me, we get function. I'm going to change the window a little bit just so it's a little bit easier to see. Go from -5 to +5 and -5 here. Oops, I'm -5, +5. Just shrink down the scale a little bit just to make it fit in there a little nicer. Okay, and so here's our, I'll do it again on this one more time. We'll make our X-min 0, our X-max 10. Let's see if that frames it a little bit better. That's a little bit better. So let's slide a picture of this out. This is what it's going to look like when we graph it. It's got that square root curve. It's kind of a half of a sideways U. So that's what they're going to look like, by the way. Square root functions are going to be half of a parabola on its side, either going up like this one or down, depending upon the graph and what the A value is. So that's the graph of it. We can find X, Y values for that, but the domain and range. How do we find the domain? Well, the domain is going to come from what's underneath the square root sign. Normally, our domain was all values greater than or equal to X, or greater than or 0. Well, to find a domain, we're going to have to solve the equation X minus 3 equals 0. What makes that value 0? Because we can't go smaller than 0. So that would be 3. So we have to pick values, and if we look at our graph, that kind of helps us. All the values on this graph are to the right of 3. Here's X equals 3. All values are to the right. There's nothing to the left. So our domain would be all reals, bigger or smaller than 3. It would be bigger than or equal to 3. If our graph was facing the other way, then we'd have less than or equal to 3. And that might happen if you did the opposite of X. If X was negative, that would reflect it over the vertical line X equals 3 if that were the case. But we're still facing right, so that's what's going to happen with the domain here. Our range is going to come from the K value. Remember, that's our up and down. So our K value, if K is -1, see H is 3, H equals 3, and K is -1. We notice down here at 1, 3, -1, that's kind of the beginning of where our graph is. It's the start. All the values are above -1. You can clearly see they're all above this imaginary line. They're above it. So our range is going to be all reals, or real numbers, where Y is greater than or equal to -1. So we look at the H and the K, that tells us how the graph's been moved and where to center it. It helps us for graphing purposes too. We can look and say, okay, it's going to start at 3, 1. And all I need to do is get one more shape. If I really wanted to get some accurate points, I can just go to the table and I can scroll down until I find something that isn't so bad. 7, 0, for instance. That would be a good point to graph. So I check those points, make a sloping curve, I'm good to go. Okay? So that's square root functions. Let's get down here. You can look at this example, example A, if you'd like to. It's similar to what we just did in example B. Let's go down to example C, though. In example C, we have a cube root function. In cube root function, let's just plug it in our calculator. If you missed that, rewind and go back and plug it in. But let's remember how we get cube roots. 2, and then we want to get cube roots, so we get math, and number 4 is a cube root already. We can also do 5. You put 3 in first, and then we'll make it a cube root for you. Do any root you want. But 2 times x minus 4 inside. Now, when I want to get outside the root sign, arrow over, and then the last one plus 2, and we graph it. Okay, and that looks like it fits pretty well in that window. We got the general sideways S shape, so I don't need to change my window for this one. Here's the graph. If we want to get some values on either side, first of all, what's our H and K? If we had to graph this by hand, our H and K are going to tell us where this is centered, right? Our H is going to be positive 4. Our K is positive 2. If I go to the graph 1, 2, 3, 4, up 1, 2, we can see at 4, 2. That's kind of the center of the graph, isn't it? Where things kind of go either way. So what I would do at this point, if I really wanted to graph this one by hand, is I go to my table and I find a couple points on either side of 4, 2. Looks like 3, 0, and 5, 4 would be some good points. So over 3, 0, over 5, up 4, and then I could connect it with that smooth curve and have those 2 points. If I couldn't just drag it out of my calculator. Okay, so domain and range, that's the second thing that we need in this problem. Well, what was the domain before we moved it? The domain before we moved it, if we looked at the parent function, was all real numbers. So if you shift it up, shift it down, shift it left, shift it right, it's still all real numbers. And our range is still going to be all real numbers. So that no matter what we do to manipulate this equation, okay, move it up, down, left, right, okay, even this one, multiplying by 2, okay, squashing it, stretching it, whatever we do to the equation, that will also affect it, but we can find those values, graph it anyways, and see what happens. So all real numbers for domain and range, it's going to work no matter what we do to manipulate the cube root function. So after completing this lesson, I will be able to graph functions and state the domain and range of the given radical function. I believe we explored how to do that today. Bring your notes with you tomorrow in class and be ready to practice. Good night.